Good morning, everyone. Welcome. I just had my hand signal that it's time to get started. I know it's about 2 minutes early, but that's good because I've got like an hour worth of material to squeeze into 45 minutes. So welcome to those of you who haven't met me before. My name is Rafał Lukawiecki. I don't work for Microsoft. I have never worked for Microsoft, but I have worked with Microsoft for 27 years now. And in the last 12, actually more, almost 13 of those 27 years, I have focused on what used to be called data mining, then it was called predictive analytics, then it was called advanced analytics, then it was called data science, which feels like today, but no, that's already in the past. Now we're calling it artificial intelligence. But it's the same thing, basically, nothing has changed. So with that one thing out of the way, let me tell you a little bit about the past, a little bit about the present and the future. If you want to stay in touch with me, I'll remind you a few times throughout this presentation about my email address and the company's website and Twitter and all of that. Feel free to ask questions during the conference and after. I always welcome them, and if there's any way I can help you on this journey, that would be my pleasure. All right, so with the introductions out of the way, let's just get the clicker working. There you go. The subject of this presentation is artificial intelligence. However, the main question that I would like to answer for you is really what is dramatically different about the AI that's now coming around for the 4th time in its history and the AIs that we had in the past. I also want to warn you about some issues and some problems that I know not only many of you will experience in the future, but some of you are already suffering from. And I also want to give you an idea how these things could be solved so that the future is a little bit easier and safer and hopefully more successful for all of our customers and people who use your systems and your software. I want you, if you are willing to do so, to stay in touch with me. And you can register for our newsletter, project.botcelli.com/connect. We don't spam often, only a few times a year at the most, and you can always unsubscribe. It's always interesting to see who signs up to my newsletters over the time. Majority of them are people who work with machine learning, but a lot of them are DBAs, IT pros, and developers too. If you are interested in learning this a little bit more in depth, I happen to have written the first ever in the world course that focused on Microsoft R, on Microsoft Azure machine learning, and the SQL Server technologies for data mining. I have now trained some 350 data scientists around the world. I am revising this course right now in view of the recent announcements. And if you happen to be in Dublin, London, Oslo, Prague, Stockholm, or sometime next year in Chicago, we're not sure yet whether it will be April or May, I would welcome you for this 5-day in-depth torture on what makes your models valid and suitable for production use. Everything, including the blow-by-blow description of the course, is on project.botcelli.com/courses. Let me quickly introduce myself in terms of the work I do. Why have I been in business all this time? Or indeed, why do my customers need AI, ML, and data science? I can summarize in 5 points. I wrote a nice essay. I think it's nice. That essay is about 4,000 words long that describes this in a way that you could hand to your boss or a colleague who's not sure about these technologies. But basically, it hasn't really changed for 12 years. Customers want to discover the reasons they fail or succeed, and they don't understand necessarily why, but they know the data can answer it. They want to understand their own customers' products and patterns and do something with it. What? Typically, more accurately plan the future, but sometimes also look back into the past to understand what went wrong that they didn't understand before. A lot of my customers want to experiment before they make a decision. Instead of risking something very big and expensive, you can do it on a selective, small-scale basis. But how do you know that you have succeeded? Just seeing that your average sales went up is very often misleading. Sometimes when sales go down, that's actually success. And when sales go up, it can be a failure. That's not always so straightforward to people who haven't worked in this area for a while. But definitely looking at averages is one quick path to statistical help. The newest reason why my customers use me is because they are increasingly building autonomous systems that make intelligent decisions. And in summary, that's why I've been in business for the last 12 years. So how do I do it? Or put it widely, how is it done today? Well, today, in general, you start with a business problem, you get some data, you build some models which solve the business problem, which change the data, which change the models, which change the business problem, and it goes on. One of the very frequent questions I get asked is, where should I start? I have a lot of data. I usually answer that question by saying, throw away all the data and find the problem first. In general, everything I have done starts with the business problem first, and if you don't know what the problem is, well, you better find that out, because just digging in data to find something we could use technology for is fun for the geekery of it, but it doesn't usually translate into successful projects. I have also found out in the last, actually almost 20 years of doing this and similar things in business intelligence, that you always need 3 different mindsets on the project. Someone who knows the business, the domain, someone who knows the data very well, maybe the DBA, maybe a data warehouse expert even, and someone who understands how to build these models. And I keep changing that part of this most stolen slide from my presentations. I've seen it now in 12 languages in the world, different colors. It's kind of how I can date where it was taken from my deck. It used to be called the advanced analyst, the data miner, the predictive analyst, data scientist. I haven't made up my mind what I'm going to call it next. Probably the AI expert, whatever marketing tell us. Remember, the names changed, but the job actually has stayed almost exactly the same. In fact, it predates me. For example, a project I do quite often is some form of VIP analysis. Everybody wants to do lifetime value predictions for customers. It's an easy project to do, usually succeeds very quickly. Well, it starts with asking the business a question. Can you tell me, what happened here? PowerPoint is rebooting. How exciting is that? Okay, let's just restart that. In the olden days, it would just crash. At least it rebooted here. Sorry. Okay, let's not do that again. Where was I? Oh yeah, you talk to the business and you ask the business, tell me what's a VIP. And the business says, well, I don't know. So they talk to themselves and they talk to someone else, and then they eventually tell you, well, VIP is someone who over a long period of time has bought lots of stuff from us. Well, that's good. Do you have a row of data that shows me the customer and all of their purchases at the end of, what shall we talk about here? Last 2 years, 3 years, lifetime? That's another thing we need to discuss with business. Yeah, we have data like that. Great, let's build a model. Maybe I'll use something old-fashioned like linear regression. Maybe I'll use something crazy like a deep learning neural network. Typically not. Typically the old-fashioned stuff works better for this. But whilst marketing yourself to others, of course, we all do deep learning every day. The important point is that I have built a model that hopefully can predict now what will happen to a customer you haven't yet been selling to for a while. As a result of that, maybe you will change the business and you will target your VIPs better, but something uncomfortably true is happening behind the scenes. What? You know very well instinctively that as soon as you deploy a model like that to production, things will change. Because you will spot fraud, fraud will disappear. Your model has to stop working. Because you are targeting VIPs better, you will change not only your own customer base, but maybe even your own market. And that is, in essence, how we have been doing artificial intelligence for the last decade and a half without necessarily calling it that. What is the most important part of this picture, however, is not so obvious. It's a little tiny connection between the business changing and the machine learning models having to evolve. Let me just flash that arrow once again in a moment. So where do we start in this cycle? You've built some models. As a result of that, your software makes some fabulous decisions, and you are targeting customers better, you are assigning credit scores better, maybe you are projecting your energy use better. One way or another, you have changed the business, but you are not alone. Your customers are responding to your actions. Your competitors know you are doing this. As a result, there is a much bigger thing changing around you, which causes your model always to get worse and worse and worse, sometimes very quickly, sometimes within a matter of months. I question models that change that quickly, but it does happen. Usually, models will degrade over a period of 6 months or longer. I have never seen models that last years in this business. So, how do we make that arrow happen? Well, we rebuild the model. For a period of time, you do it automatically. You can automate model retraining with new data that represents the changed world. But as long as you do it well, you observe that something's going to happen behind the scenes. Even though you are rebuilding and retraining this model, it will keep degrading because there will be things you have never even thought about when you built it in the first place. So a little bit of tracking, control, validity, especially tracking of validity and predicting when a model is going to become invalid is essential to spot that. But one way or another, your models are changing. What does that mean? They are making different decisions tomorrow than they would have made today. Tomorrow, your model can tell this customer, yes, we are happy to give you a loan, even if yesterday the model said no. Have you noticed what we've just built? We've just built a system that is making autonomous decisions to maximize your objective, one that senses its environment, increases its chance of success, and at the same time, all you are doing is just tracking some validity. That is artificial intelligence. If you look into the probably most quoted book that explains what is artificial intelligence today, Russell and Norvig, about 1,000 pages, it makes great bedtime reading. It's a popular book. How do you know it's a good popular book? Because secondhand, it still costs about $60. You know, that's not many books you'll buy for $60 used nowadays, unless it's shipping, of course. If you think about that, Russell and Norvig, more than a decade ago, gave us an idea of what AI would be. And we've built it without ever calling it AI. Realistically, today, every bit of artificial intelligence that you are building, in fact, I could pull out a finger out of thin air and say the proverbial 99% of AI is built around this concept of automatically or manually changing machine learning models. So, are we done? Can we go home or to another session? Is that it? Well, obviously, I would be presenting this session if that was it. So I'm going to tell you what's different and what's going to change, but let me quickly walk you through some technologies that I have been using so far and the ones I will be using in the near future. I've been using SQL Server data mining for a very long time. In fact, not many people in this room presume I know that data mining has existed in SQL Server since 2005. Neural networks since 2008. Not very good ones, but we've had them. On the other hand, pretty good decision trees, pretty good regressions, and a lot of stuff was there. Easy, worked with Excel. I still use it today because it's so easy to put things together. Then, about 6 years ago, I started using R and Microsoft R Server because I needed something to do better statistical analysis, but more importantly, to have access to this 10,000 or more packages of most advanced, just invented last month and maybe 3 months ago, software that solves problems that my customers have that sometimes I didn't even know we had. And I have been using Cortana Intelligence Suite, in particular Azure Machine Learning, that's Azure for Americans, Azure Machine Learning that has been changing also recently, mainly because it has a nice combination of a graphical user interface and ready-to-use web services, that let me get started on a project without having to build anything. In fact, in the last 2 years, I think every single customer project I have done had a combination of all of those three. But let me now take you way before all of that. Let's talk a little bit about the past of AI and perhaps a few words about what I've been doing in that past. AI is not new. Early ideas about reasoning started in the medieval days. Leibniz conceptual calculator in the 17th century, Boolean algebra in the 19th century. That's where all of those Boolean values come from. Turing machine probably is the first time we are waking up to understanding what AI could be, but the term artificial intelligence really isn't properly coined until the Dartmouth workshop. That's Dartmouth in US, not in UK, where some forerunners and pioneers of this, I guess, science today, including McCarthy, Minsky, and a few others, came up with the term. Then things start moving much faster. Around 97, everybody says, well, if a computer could beat a chess player, that's really intelligence. Well, we've done it, and everybody said, yeah, what's next? That doesn't feel very intelligent. So people said the next thing will be language translation. If you can do that, that's like, you know, the most amazing thing on the planet. Yeah, we've done that. In fact, we've done that in 2017, earlier this year. Look how fast time passes. And we have now live translation while you speak. And do you feel like the world has become more intelligent? No. Because the target and the goalpost is moving as soon as we get there. That's one of the fascinating things about AI, that whatever you are hoping for today, tomorrow is going to be, you know, like yesterday's big data. Who's talking about big data? It's like all small data. Come on, you know, that's dead in the water term. Never liked that term anyway. A very quick and rough history of programming. You may disagree with it. This is my perspective on it. From wiring the hardware, writing in assembly languages, then formula translation into symbolic functional programming that never had a computer strong enough to run, through structured era of languages such as ALGOL and perhaps C, declarative programming much later, and eventually the winning paradigm of imperative programming paralleled our move from hard-coded to the machine, compiled, and currently we are enjoying the interpreted era with, of course, languages such as Python and anything based on the Java virtual machine. I want to point out that this is going backwards. I want to point out that we are increasingly using hardwired stuff into GPUs, into gate programming on NAND devices. In fact, we are happily mixing all of those outmoded approaches with new. And that's very important to me, because in a moment I will, well, towards the end of this session, I'll tell you about a language from the past that is going to come back, and you are going to enjoy it. But before I do it, let me just praise a little bit my own past. Just humor me for a moment, okay? When I started, I had to learn BASIC first. Yeah, okay. Then, my first programming language I've learned was actually the first programming language ever invented, Formula Translator. After that, I had a little bit of a dabble in natural language processing in languages as fabulous as Novel 4. I was lucky to learn Prolog from the professors who invented Prolog, so that was kind of fun learning experience. Then a little bit of symbolic equation solving, this thing that disappeared called reduce. Yes, that was done on mainframes, on a CDC Cyber 72. I know I don't have enough gray hair to prove it, so you kind of have to trust me on that. LISP came in, and then my first serious, long-running project that was in production for a long time, cannot tell you which agency and where in the world, but it was a nuclear safety management system that ensured that there was never too much of something unpleasant in one place. I had to write this software, and when I was writing that software, I had to make sure it was perfect, that it would never have an error. Unless the computer crashed, I could not make the software make a mistake. Therefore, I didn't write it in an imperative programming language. I wrote it actually in microprolog because that allowed me to reason, to use logic and the perfection and predictability of this logic. But, none of that was really fast enough, so then I spent ages in C, C++, and Pythons and Javas and whatever else you have. You know what the past taught me? Is that we have lost something. Provability. When I was writing that system in Prolog, I had certainty that none of you have in this room that the software will definitely work and it will not make the wrong decision unless the computer physically failed. Today, yes, I do everything probabilistically. Every machine learning model, every Bayesian reasoning system is a probabilistic fuzzy thing, and I love doing this, but I miss that certainty. In the past, the ontology, or in other words, the purpose of every variable, each bit of code, data, relationship was clear and well understood. One of the greatest pleasures of my life was speaking on stage with Neil Armstrong, a guy who blasted off to space not very far from here. If you have time, make sure you go there. That's insane. It was a great presentation he gave. Our presentation was about the failures in software launches, which was kind of fun because that was when Microsoft were launching Windows Vista, but that's another story. Anyway, one of the things I learned from him at that time was that unless things completely blew up, as they did in the case of his landing, of course, if you don't know the story, you owe it to yourself, everything had to be 100% certain, everything had to be provable, everything was not probabilistic. Edge cases were testable, and there were no black boxes. If you said yes, you knew why. If your computer said no, you knew why. You know what? I miss that. And that worries me because some of that stuff is going to disappear. Let me take you through the near future a little bit quicker than the past. Why? Well, because you hear a lot about it. There are plenty of presentations at the conference, but Microsoft R Server, oops, sorry about that, name change. Microsoft Machine Learning Server, yeah, it's the same thing, just a new name. Microsoft Machine Learning Server is the very near future for most of you trying to do serious ML in the Microsoft world. Really, they had to rename it because it's not just R. It's now do it in Python or R and possibly in other languages in the future. And in Rafal's quick summary, this is the essence of what it comes with. Lots of stuff of which fascinatingly powerful and fast algorithms for building traditional probabilistic machine learning models. Look at those numbers. Stochastic dual coordinate ascent is a bit of a mouthful. It's a bit like a support vector machine on steroids technique. 1 billion columns by 1 billion rows. Neural networks, GPU enabled, infinite numbers of rows, depends how many GPUs you've got. Easier deployment. I don't know how I'm supposed to pronounce the Microsoft R Server deploy package. We just call it Mrs. Deploy in my company. Does it look like that? Yeah? Okay. Well, Mrs. Deploy makes life really easier because she ensures that you can provide a lovely web service API to your machine learning models, but she also helps you install and deploy things and even get a remote command prompt if you need to test your models against a server. And of course, all of that built on the acquisition Microsoft made a few years ago of Revolution Analytics, now not only for R, but also for Python. Azure machine learning is changing. I hope you have seen some of the announcements yesterday and you went to the presentation. Today, wonderfully graphically user interface-based way of building machine learning models is becoming code first. Write it in Python, in R, full support for Git, multiple tools from Microsoft and others. And also, Microsoft are shifting their focus away from providing a framework towards you choose the framework. So it's much more of a production-ready manageability environment in Azure than just a nice GUI for building pretty powerful machine learning models, as well as Put it wherever you want. You want to run it inside your own VM using Docker, no problem. You want to deploy it to Microsoft's new machine learning server, that's fine. You want to put it on SQL Server 2017, that's absolutely fine too. So a ton of stuff I know I will be using in the very near future. By the way, the preview of this is already available. It's a little bit hard to find it, so if you go to the Azure, that's Azure, portal, and you navigate your way to cognitive services, that's where the link for the preview is, and if you click on it, you'll get access to it today. Really what is happening is a democratization of deep learning. And you know what, just like I have never liked the term big data, and I'm on record 5 years ago saying what a bad term it was, I don't particularly like the term deep learning because it's overrated, because it's abused by marketing, but it is useful as an idea. Deep learning is essentially a compute optimization that allows you to prune down the search space of all possible alternatives as you are building models. And in that sense, it enables deep neural networks. That's how it's done today, and thankfully it's getting there for other algorithms, and it's helping us optimize decision trees and arguably more useful techniques than just neural networks. There are many frameworks, of course, that do that, but it will become very popular. Everybody will be using it left and right. So is everything really perfect? Is everything fine with all of this cool stuff in ML? No. The black box dilemma. Okay, if you had a sense or a strange feeling down there, it's usually down there, that building these incomprehensible neural networks to do every job of our life is a little bit odd because we don't know what they do, you are with me. It is impossible to understand how a neural network, a deep learned system, makes its decisions. Unlike regressions or simple decision trees, nobody has a clue. So sometimes, in some legislations around the world, we can't even use them. In some countries in Europe, notably in almost every European Union country, but that excludes, for example, Norway, and I suppose soon United Kingdom, you cannot deny somebody a loan on the basis of something you cannot explain. So if someone says, can I have a loan? And you say no, and the credit scoring system uses a neural network, sorry, you're going to be hounded by the regulators. That's not allowed. I believe that in US you can skirt around that a little, but you are roughly similar to EU. How do you like the idea that you call a call center and you say, I am interested in going over, to you and talking about this fabulous technology, and I think I have something we should do together, and the person on the other end says, computer says no. If you feel that this is already happening today, then of course I share your feeling, but this is going to happen much more. There's another problem in a black box. They are very easy to overtrain. What does overtraining mean? It memorizes what it has seen before, and it's extremely poor at reasoning and transparency. It has no clue what it has seen, which is partly why they are so good at image analysis, at sound and voice recognition and translation, but they are very poor at reasoning and making judgment. However, economy is against me. More and more developers are quite happy to build an overtrained neural network deep learning model because it works for a week. And what happens in a week? Who cares? I just build a new one. Oh dear. So am I saying that actually overtraining is a good thing? I thought I would never live to this day, but that is exactly how people are using it on an increasing basis. Do you know why? Because it's cheaper to rebuild an overtrained model on a weekly basis than to pay someone to understand what they are doing. No disrespect to people who build deep learning models, because that's also tough, but that's becoming automated. You just push a button, it trains itself, it makes decisions, and who cares? Basically, what we are doing is we are observing the local minimum. We are observing the local state of the system as it moves, and statistics is dead. Forget about Tukey, Pearson, and Fisher, and everybody who came, anybody who said that transparency is important and, you know, all of that, right? Ooh, so who's going to win? Well, this is going to be an interesting few years, perhaps a decade. Those black boxes already caused financial losses. Do you remember that guy, that financier who went to jail in Singapore because he bet his bank's money on a black box and then lost everything? And unfortunately, he couldn't blame the computer, so they put him in jail. Do you remember not the last one, but the prior 3 flash crashes on NASDAQ where trading had to be reversed? In fact, it's going to cause human loss. I hope that those autonomous cars, which I absolutely adore, are not going to get to the point that, okay, today we killed 5 people, so we better retrain the model so only 1 person dies tomorrow. Do you see a certain macabre vision here? Good, I'll stop because I don't want you to be too worried because I have a solution to this, okay? So the solution comes in a few moments, but that's what's going to happen if you rely on black boxes alone. You will be unable to deal with exceptions, edge cases. Human understanding will become secondary to simple economics of building a machine that learns something about today and assumes that tomorrow is okay. And who cares if we upset 5% of customers? Who cares? Those 5% will go to your competitor or somebody else, and you're going to lose business, and you're going to probably end up having serious issues in terms of compliance and regulatory responsibility in some countries, but not in others. By the way, deep learning is going to be obsolete very quickly. Well, how quickly we disagree. As soon as quantum computing comes and becomes real, so some people say, oh, it's like 20 years, some people say maybe 50 years, all of the deep learning and majority of neural networks, no longer necessary. So that's kind of provides a boundary on the bad stuff, okay? Of course, it will cause a lot of other issues, like encryption, as we know it, will disappear, and there will be no internet security for a while. But yeah, you know, that's a different presentation in a different room, so I don't have to go there. All right, this is the part you've been waiting for. Is there anything we could do with that? Is there anything that could be done to solve that issue and get still on that cheap economic bandwagon of machine learning, deep learning today, but have a little bit more safety? Yes. Forgotten past and a little bit of present. Let's hybridize the best of those 50 years ago, 40 years ago, 30 years ago, but maybe not 20, because that's when we started doing things differently. A little bit of logic and symbolic programming that gave us explicit ontology, provability, ability to test edge cases, ability to reason with modern machine learning, which is exactly where those approaches from the past sucked, to be honest with you. Building a neural network in LISP, yes, you can do it just to learn, but not in reality. It wasn't powerful enough. Languages such as LISP, have you heard of Clojure? I see some of you have. That's LISP. It's just a variant of LISP. Prolog, together with machine learning or deep learning and a fast in-memory data. And now you think, here's a crazy guy just talking about stuff nobody does. I know you were going to think that, so I have a few examples. I'll start with one some of you may have heard about if you travel a lot. Have you heard about ITA matrix? Okay, I'll give you the name you know. Have you heard of google.com/flights? All written in Lisp. Project started 2003 and combines machine learning and Lisp. Okay, what about Reddit? Really? Written in Lisp. What about Y Combinator? What about countless examples of early examples, but sure examples of solving the problem of that black box mess with the provability? Why? Why does it work so well? Because logic programming enables us edge handling. It enables us to reason, whilst machine learning is extremely good at doing the heavy-duty lifting of concept recall and pattern recognition. The reason deep learning is used almost only for image recognition, language recognition, speech and translation is because it is a primarily concept recall and pattern recognition task. It is not a reasoned task to a large extent. Why languages such as Lisp or Clojure? Maybe it's a personal preference. Lisp is the second oldest programming language, so in some way I feel, like vindicated for having to learn it a long time ago. Maybe, but maybe because it's one of those few languages where code is data and data is code. I know that the security people in other rooms are getting very upset when we say code is data, because of course that means far more creative viruses and malware will be possible thanks to this technology. But the truth is that when your code can modify itself infinitely, you have the kind of expressive power that logic programming and symbolic logic programming and temporal logic programming relies on. Deep learning is just an optimization mechanism, and thank goodness Microsoft for giving it to us, because it's making it economical, and I don't think I have to explain why in-memory is good because of its ultimate speed advantages. Before I summarize my session, I prepared a tiny, tiny, tiny little demo. How do you demo these concepts? Well, I thought, to those of you who have never seen Lisp, I'll show it to you just for a minute, okay? So you'll go at least out of this room and say that you saw a little bit of it. So using Norvig's fabulous set of algorithms, let me show you just an example of what this could look like. Younger or older people in the audience? This is older people, this is younger people interface. You seem rather in the middle. Okay, I'll stick with the older, okay? Since more gray hairs here. Young people, just close your eyes. All right, I'm not gonna walk you through code because that's not my point, but what I want to show you, other than the profusion of braces, the brackets, some people say this is a defining feature of this programming language, I want to show you how few keywords there are. This one, this one, this one. In fact, the green things seem to be repeating itself. Lisp is a programming language in which you could do everything with 3 words. Because in this programming language, the first thing you do is you define your own programming language. That, and so on and so on. They are all examples of things which I am, or Norvig, is defining for me to use. So the first thing you do, almost like in domain-specific languages, domain-type languages, as some people prefer to say, you define your semantics and syntax, which is very easily done, at which point there is no difference between Lisp and this language. In fact, if you wanted to redefine do and unless and whatever else you could, because there is no difference. You could redefine a 1 into 2 if you wanted to, but that's, other than a good fun thing to do, not a very recommended thing. The only thing you cannot redefine is nothingness, nil, where everything begins in Lisp. Everything begins with 3 words and nothingness, which is kind of philosophically beautiful too. All right, I can see you kind of looking at this, what this guy is going on about, so let's have a little bit of fun. We're gonna play a little game over here. So this is a very short piece of code that implements some logic for artificially intelligent game, and I'm going to run it. What a fabulous language that has things that are called slime, isn't it? All right, let me just get that read. Oh, dear God. Oh, what have I done over here? I need to restart my slime. Sorry about that. I just, oops. Now you can say, we've seen a demo in which the guy oopsed on something in Lisp. I never thought you would live to that, probably. All right, let's get slime started again, and we have, can we have my org battle, please? No. Let's just kill this guy. This is very real world. This is what you do when everything crashes. And we start then again. Okay. That's better. That's where we're supposed to be. And let's evaluate that once more. This time, Raphael, don't over-evaluate. And we are ready to play the game of org battle. You can imagine that this is basically an AI engine that would be embedded in any game out there that you play, except we play in text. So who are we going to kill today? Let's see. It looks like a malicious hydra with one head is the easiest one to stab. So we're gonna stab that malicious hydra, which is monster number 5, and it died. That's nice. It's decapitated. Can you see? Decapitated fully, problem out of the way. All right, who is the next one? I would go for the slime mold. Let's double stab the slime mold, which is monster number 8, and because it's a double, we're gonna go for the hydra number 7. And we win again. Isn't that good? There's a roundhouse attack on everything. And again, and again, and look at that. Oh, dear God, I think the slime, no, the brigand cut my arm, and a hydra attacked me, and if you haven't noticed, I have been killed. Game over. Nil. It always ends with nil. What has happened here? Other than the minor demo failure, which was very exciting. What I have shown you is that in a few lines over here, fairly straightforward lines of code, only about 200 lines of code, we're able to encode logic which could represent the boundary conditions, which could represent the limitations or the rules that your system has to follow whilst giving loans. Your game has to follow while letting people play with it. The knowledge was encoded in the code as a few facts. You wouldn't do it in Lisp. You would have that section obviously provided from a machine learned model. But the rules which were sitting above it, in 200 lines, I was encoding the limitations and the framework that would provide me with a kind of correctness that I hope will save us from trouble in the future. Okay. So is it all about the language? Is it all about the framework? Is it all about finding the best algorithm that exists? No. If I could share with you one lesson from maybe the not last 12, but 5 years. I've been looking for too long for the best algorithm out there. I have been swayed too often by people telling me that the next best language is X. And here comes he saying that it's Lisp. Don't antagonize about the choice because your data, and in particular, your human intuition are far more important, and you should trust them above the choice of the framework or the algorithm. Algorithm is not the bullet. If you would like to learn more about any of that, I would be delighted if you stayed in touch. Connect with me at projectbotticelli.com/connect. Don't forget the 5-day torture in which I make you make your demos go funny and we fix them then. And above all, I hope that all of this in some way will give you an idea where the future is headed. I would appreciate it very much if you would evaluate this session using whichever means are convenient for you. But other than that, all I've got to say is thank you very much for your attention. Goodbye.